Yo, 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 yo! Welcome to my channel. Right, today's tricky question is gonna be my favorite, another of my favorite type of question, which is integration. Yay! All right. So it says the diagram below shows a container with parabolic cross-section area. Good. So this here is a parabola in the function y equal to ax squared plus bx plus c. All right. For feeding pigs. Cool. All right. The farmer wants the container to have a volume of 0.8 meter cube. All right. So they want to have a volume of 0.8 meter cube and calculates that the depth d. So from here to here. Wow, that's hard to see. Can you guys see it? I'll use a can I use a thicker one? I'll use a thicker one. Yeah, here. So this is the depth, right? Just like here, same thing. So the farmer calculated that the depth D must be 20 centimeter. First one, is it correct? So that's the first question, is it correct? And second, if it's not correct, what changes could be made to the dimension of the container? All right. So first, we have to find out how to get the volume of this container. What's the formula to get the volume of something? So the volume, I'll use back blue pen. The volume of the container is equal to the cross-sectional area right, multiplied by the length. Yeah, length is equal to the volume. Right? So we've got an area, we multiply by another dimension, which is a length, or you can call it height, the width, whatever you call it. And it gives you the volume, right? The three dimension of the object. The third dimension of the object. All right. So first, we know the length. We know the length in here is 2.2 meters. Right? And we want the volume to be 0.8 meter cube. But we don't know the cross-sectional area. But we can find it out, right? Now, to find out the cross-sectional area, we need the function first. We need to find the function first. Find the parabolic function first. Right. So looking back here, if we treat this as let's draw an x-axis on it, all right? Let's be fun and draw an x-axis on it. Oh, it's hard to use black in this case. All right, I'll rub this off. So we know it's a parabola now, you know. So let's draw an x-axis here. And the y-axis, I'll rub this out. Right. So we know that the whole diameter, I would call it, I don't know. The whole diameter of this bit is 50 centimeter. That means if it's a parabola, the shape must be symmetric. So it must be 25 and then 25 here. Right? It will make sense, right? But since we already got a Cartesian plane on it, so this will be negative 25. All right. Now, there's a trap here. Right, mind you, the measurement here is in centimeter, but we wanted meter cube. All right, so you can convert this to meter, right, first, or you can convert everything else to centimeter and convert to meter cube at the end, which is quite confusing if you do it that way. So let's just convert the 50 centimeter into 0.5 meters. All right, so each of them will be 0.25. Right, so 0.25. Right. And the farmer is assuming that the depth is 20 centimeter, right? So that would be 0.2. So this depth will be 0.2 meters. Rightio. So let me just draw a improper one here. I know it's not very symmetric, but hey, this will have to do. So this is negative 0.25, and this is 0.25. Right, they're both the x-axis, the x coordinate. And this point we know is 0.2, which is the y coordinate. Negative, sorry, in this case, because it's below. Right, so we know the parabola function is in the format of a equal to ax squared plus bx plus c, correct? And we are given, we got three variables, right? A, B, and C. But don't worry, we got three pieces of information. 1, 2, 3. We should be able to find out everything. All right, let's look at the y-intercept first. All right, let's just assume that this is the y-intercept. Well, it is the y-intercept. We know if it's a parabola. The minimum will be the y-intercept. All right, so this will be negative 2. So when x is equal to 0, you know, which is where the y-intercept is, y is equal to negative 0.2, right? So negative 0.2 is equal to a multiplied by 0 squared plus b multiplied by 0, right? Plus c. So this would cancel, becomes 0. So negative 0.2 will equal to c. Correct? Cool, we already got one. All right. So let's use the other 2 points, which will be our root, right? With our x-intercept. So the other 2 points is when y equal to 0, x is equal to negative 0.25 and 0.25. Right, we've got 2. We've got 2 points here, right? So we can have 2 sets of equation. So the first one will be 0 equal to a multiplied by negative 0.25 square plus b multiplied by negative 0.25, and our c is negative 0.2, right? This is our first function, and the second one will be 0 equal to a multiplied by 0.25 square plus b multiplied by 0.25 minus 0.2. Yeah, cool. All right, so let's do some rearranging. So let's bring the 0.2 to the other side. Becomes positive 0.2. Same here. Yeah, we can do this simultaneously since they're pretty much the same. All right, but I mean in the test, if you can't do, if you're not as good as me, that's just joking. In the test, please do one by one, you know, just to reduce the chances of error. So let's go negative 0.25 square. All right, let's use a calculator. Whatcha? There we go. So negative. Oh, so when you square, when you making negative to the power of anything, we're meant to put a bracket there. So negative 0.25 to the power of 2 give you 0.0625. So this is 0.0625a, right? Plus, now negative 0.25 times b is just negative 0.25b. Correct? Positive plus negative is just negative. Cool, that's the first one. And now this will be the same, 0.0625a. But this one is multiplied by a positive, so it will be plus 0.25b. Right, so we've got 2 equations with 2 and 9. We can solve it simultaneously, all right? I am actually going to be lazy and use the calculator method, all right? So let's go to calculator. So we go manual. We go to the, what's it, equation, where's the equation? here, equation. We go simultaneous. Number of unknown 2. Right, so we have to arrange our function in this form, right? Which is we already got there. Okay, so 0.0625. I'm entering the first function in there, and then there will be negative 0.25 in here, and the next bit which is just 0.2. All right, next function, pretty much the same thing, 0.0625, but this time is positive 0.25, and it's 0.2. All right, and after that we go solve. We've got 3.2 and 0. So 3.2 as our A and 0 as our B. So therefore, we got communication mark. Use graphic calculator and then solver. All right, and then therefore A is equal to 3.2 and B is equal to 0, right? And we already know C is negative 0.2, right? So therefore, the function of the parabolic function of the cross-sectional area would be y equal to 3.2x squared minus 0.2. Yeah, cool. Right now, and let's just double check if this function is actually what, does it actually give this particular graph, give this particular shape. And we can do that through decimals, or in the exam you can do it in your calculator, graphic calculator, just to make sure that the root is right. All right, just to make sure the root and the x and the y intercept is correct. So in this case, I'm going to use decimals. There we go. So we got what we wanted. So it cuts at negative 0.25 and 0.25, and it has a depth of negative 0.2, right? Which is 0.2 meters. Yeah. So all this is in meters. So this is what we want, right? The next step is to find out the cross-sectional area, which is this, right? Now, of course, you can do that, but what I'm going to do is a little bit more lazy. I'm going to try to be lazy here. I know parabolic equation, they're symmetric. That means at the middle axis, from this point onward, so this side, right, is the same as this side, right? Because they're symmetric. The whole thing is symmetric. So instead of finding all the area, I'm just going to go find half of the area and multiply by 2. All right. So what I meant is instead of finding from here to here, I'm actually going to find from here to here and multiply by 2 at the end. Right? Or actually, in this case, I'm going to find the positive side, this one. Yeah. Just do this. I find all this area, or find the area of the red color. Yeah. And then multiply by 2. All right. And to find area between two curves, we need to use, yeah, hopefully you said definite integral. Okay. Cool. Let's start. So we're integrating. Since we're looking for the area of the red side, I'll use red. All right. So we're integrating from 0 to 0.25. Right? And then we always go top minus bottom. And we are integrating with respect to x. All right, communication mark, very important, guys. Now, and then you have to ask yourself, okay, which equation is on the top? Now, our x-axis is on the top. Yeah, our x-axis is on the top. So it will be 0, y equals 0, which will be 0. Minus, bracket, which is on the bottom, our parabolic function, right? Our parabolic function is on the bottom. So will be 3.2 x squared minus 0.2. integrate with respect to x. Cool. Let's expand the bracket, and we can just ignore the 0 because it doesn't really matter. So the 0 is gone, but we have to expand the negative 1 into the brackets. So it becomes negative 3.2 x squared plus 0.2, integrating with respect to x. Right? And we can go integrating. Let's go. So this becomes negative 3.2 x cubed all over 3 plus 0.2x, right? From 0 to 0.25. All right. Once you finish integrating, note the integral sign is gone and the dx is gone. Okay. Don't keep it there. All right. So let's go. Now we know that if we sub 0 into both of them, it becomes 0 because anything times 0 and or divided by 0 will become zeros. So I don't need to do the bottom part. I don't need to do the minus bit. All I need to do is just the 0.25 bit. Yeah, you see, this is why I only do half of it and multiply by 2 because it's easier. All right, so let's go. Sub it in. Negative 3.2 multiplied by 0.25 to the power of 3 all over 3 plus 0.2 multiplied by 0.25. Right. Let's key in ISA. So we go negative 3.2 multiplied by 0.25 to the power of 3. Right? And then divided by 3. Which give us that. Can we do it in the fraction? Yes. We get negative 1 over 60. All right, I want to keep it as a fraction, so it's more accurate this way. And then the next bit is to have 0.2 multiplied by 0.25. 0.05 in fraction, 1 over 20. So it's plus 1 over 20. Right? And now let's make it to the common denominator. Hopefully by now, yeah, doing this should be year 12, right? By now you should know this is this. Right? I don't have to go through each steps. All right? Do I have to go through times top by 3 and times bottom by 3? No, I hope not. All right. So it's just negative 1 plus 3. So it becomes 2 over 60. Right? And since let's find an actual number for this. So 2 divided by 60. This is actually 0.03333333. Yeah? Oh, we haven't finished yet. No, we haven't finished yet. So let's keep it like this. I thought we were finished. All right. So this is in meter square, right? Because this is an area, right? And our unit is in meters, so it must be meter square. Now remember, this is only half of the cross-sectional area, right? And we have to multiply by 2 to get the total cross-sectional area. So total cross-sectional area, sectional area, is equal to 2 over 60 multiplied by 2 is equal to 4 over 60. Right? 4 over 60 meter squared. Right, so we got our cross-sectional area now. Right, we got our cross-sectional area, so we can sub it back into that. Right, we got it. We can put it in here now, which is 4 over 60. So now we can see is 4 over 60 multiplied by 2.2, giving us 0.8. Right, let's go. Let's put it here. So 4 divided by 60. Oh, let's go the other way, hey? 4 6 over 60 times 2.2. Yeah? Equal? Aha! See, what we actually get is, oh, I forgot what was it? 0.1, oh, let's do it to fraction. 0.146 recurring. Yes. So it's 0.146 recurring, which is not 0.8. Boom, boom. So the farmer is wrong. So that's the answer for the first question, right? Is he correct? No, he's not. Right? So let's answer it. Therefore, since a 20 centimeter or 0.2 meter depth will not create a volume of 0.8 meter cube. What's this thing called? Container. Since a 20 centimeter or 0.2 meter depth will not create a volume of 0.8 meter cube container with 2.2 meter length, the farmer was wrong. Yeah? Ooh. All right. So if he's not correct, since there's a second question there, I mean, come on. Right? Logically, you'll be thinking he's wrong. Right? Or else you wouldn't be able to do this, or else you will need to do the second question. Come on, guys. Common sense. Alright. If he's not correct, which in this case he's not correct, what changes could be made to the dimension of the container? Now, obviously you can change a lot of things, alright? So you can change here. You can change here, so you can make them wider. You can make it like that, right? But or you can make it deeper. You can go down deeper, right? That would increase the cross-sectional area, hence increase the volume. But the easiest, guys, is just to change the length, right? Because I don't want to work out the cross-sectional area again, but that's just troublesome. Let's just change the length or the width, whatever you call it, that 2.2. Let's just change it this thing, right? So knowing that we got 4/60 at cross-sectional area multiplied by a length when we want to get 0.8 meter cube, right? So 0.8 meter cube. So all we have to do is just length is equal to 0.84 divided by 4/60, right? Now that is just the same. Let's write it this way. Divided by 4/60. It's just equal to 0.8 multiplied by 60/4, which is 0.8 multiplied by 60/4. 12. Oh. So 12 meters. Alright, length is in meter, everything's in the meter. So that's it. You have to change the length of the container to 12 meter instead of 2.2 meters. Right? And that would make a volume of 0.8 meter cube. Cool. So therefore, answer the question. The length or width, however you see the picture, the length or width of the container needs to be 12 meters to 12 meter for the container to have a volume of 0.8 meter cube. Done. Woohoo! So that's it. Alright? So that's how you do this question. Look, I mean, it's I wouldn't say it's an A level, but it just doesn't really take that long. But the hardest bit is to come up with the equation yourself, right? Come up with the equation yourself with the given information, and seeing that unit, the measurement unit trap here, seeing it. So yeah, a B plus or A minus question, I would say. Yeah. So yeah, so this is how you do this question. All right. So hopefully you learned something today, and I will see you next time.